Hello friends, welcome to engineering tutorial. Today we are going to discuss about another transducer which is inductive thickness transducer. So as the name suggests, it is based on the principle of inductance, and we are going to use it for the measurement of thickness of materials. So let's get started. Now, what is an inductive transducer? Now, inductive transducers are devices in which the self-inductance, which is notified as L, or the mutual inductance M, varies due to variation of the quantity under measurement. So, in this case, as we are measuring thickness, so when there will be a change in the thickness of the material whose thickness we are trying to measure, there will be a change in the self inductance or the mutual inductance. Okay, so the inductive transducer basically converts change in thickness into a change in inductance. So the output will be inductance and the input will be thickness, change in thickness. So they are basically used for the measurement of thickness and displacement. Obviously they will be used for the measurement of thickness and displacement. So basically for in industries, the inductive transducers are used for measurement of thickness of rolled sheets or mass produced objects. Now there are various kinds of materials in which thickness of the test piece or the test material plays a huge role. So we have to ensure that it is of the right length, breadth and height. So in that case, the inductive transducer, any sort of thickness transducer, it comes into play. Now this here, the material whose thickness is to be measured is usually referred to as the test sheet or the test material. Now it can be of three types. It can be magnetic and conducting, basically iron or steel are the examples, non-magnetic and conducting aluminium, non-magnetic and non-conducting bakelite. So these are the three categories in which the test sheet can fall. So there are some pre-requirements which the test material has to satisfy. The first pre-requirement is that its properties such as permeability, which is the ability of the material to get magnetized by an external magnetic field, and resistivity, which is the ability of the material to allow flow of current through it, it should not fluctuate, it should not change, okay, and only thickness or the range of thickness which can be measured by the inductive thickness transducer is from 25 micrometer to 2.5 millimeter, and the accuracy lies in the range of 2 to 5%. So let us understand the construction and the design of the inductive transducer for the measurement of thickness. So basically the inductive transducer, the inductive thickness transducer, it consists of four parts. First, the magnetic yoke or the frame of the inductive transducer, two coils, a primary coil and a secondary coil, the primary winding or the secondary winding, the test material or the test piece whose thickness is to be measured, and the excitation voltage which is connected across the two ends of the primary winding, and the output voltage is taken across the secondary winding. Now the test material forms a part of the magnetic circuit when it is attached with the yoke and completes the magnetic path so that there is a current flow in the circuit. So the test material completes the circuit continuity. Okay, so there are many types of arrangements for inductive transducer. Here we are going to discuss only two arrangements. So this is the first arrangement. This is the first arrangement. We have a C-shaped magnetic yoke, okay, which is has two windings, the primary winding and the secondary winding. The excitation voltage is connected across these two ends and the output voltage is taken across the ends of the secondary winding. This is the test material of length L and thickness T. whose thickness is to be measured. Okay, this is the first arrangement. Then we have another arrangement in which the shape of the yoke is in the form of a M. Okay, it is a M-shaped structure. In the middle, the middle one, we have both the primary and secondary windings wound around. Same, the AC supply voltage is connected across the ends of the primary winding, and the output voltage is taken across the secondary winding. The test piece completes the magnetic circuit. It has a length L and thickness T. Now, N subscript P is the number of turns of the primary winding, and N subscript S is the number of turns of the secondary winding. So, these are the two main arrangements for the design of the inductive thickness transducer. This is arrangement 1 and this is arrangement 2. Okay, so in both the cases we have four main things. There is a yoke, magnetic yoke, we have a primary winding, we have a secondary winding, and we have the test material of length L and thickness T, and we have to determine this parameter T. Okay, so there is a relationship between the inductance of the coil, the self-inductance of course, and thickness T. Okay, there is a relationship between these two parameters which can be written mathematically as the self-inductance L equals to N square mu subscript 0 mu subscript R Bt by L. Now of course N is the number of turns of the coil, whether it can be primary coil or the secondary coil. Mu subscript O is the absolute permeability and mu subscript R is the relative permeability. B is the breadth of the test piece, T is the thickness of the test piece, and L is the length of the test piece. Both the length and the breadth of the test piece are already known. They are known from the previous the measurements. So with these two, all the known values B, L, mu 0, mu r, and the number of turns. The only unknown parameter here is the T. So there is a direct relationship between the self-inductance L and the thickness T. So the self-inductance L is actually directly related or directly proportional to the thickness of the test piece. And then once this self-inductance L is known, it can be converted into suitable voltage or current change or fluctuations in the circuit by using suitable signal conditioning circuitry such as AC bridges, okay, where there is an element which involves change in inductance. So that part we have not discussed here. We have just discussed here the basic concept or the relationship between self-inductance of the coil and the thickness of the test piece. So here we get to know that the self-inductance L is directly proportional to the thickness of the test piece, and while all the other parameters such as the number of turns, absolute permeability, relative permeability, breadth of the test piece and length are already known. So this inductive thickness transducers have many arrangements. We can arrange them in a lot of other ways, but these are the two basic arrangements. Okay, so in all these the arrangements which can be made, there will be four main parts, which are the magnetic yoke, primary and secondary windings, test material, and the excitation voltage which is connected across the primary winding, and the thickness of the test material is to be determined, and the test material is a part of the magnetic circuit which completes the circuit continuity. Okay, so here I have discussed the basic concept related to inductive thickness transducer, and we have established a relationship between the self-inductance L of the coil in relation with the thickness of the test piece or the material whose thickness is to be determined. So please subscribe my channel for more such videos related to electrical and electronics engineering and instrumentation engineering, and have a great day. Thank you very much.